Lesson 4, Sinusoidal voltage. Section 4.4, Phase shift. These are two sinusoidal voltages V1 and V2, which are expressed as V1 equals V1 m sine omega t plus theta 1, and V2 equals V2 m sine omega t plus theta 2. Where V1m and V2m are the amplitudes. Theta 1 and theta 2 are the phase angles. Omega t plus theta 1, and omega t plus theta 2 are the phases. And theta 1 minus theta 2 is the phase shift of V1 relative to V2. If the unit is radians, then theta 1 equals minus pi over 8 radians, and theta 2 equals minus 3 pi over 8 radians. Then the phase shift theta 1 minus theta 2 equals pi over 4 radians. It is said that V1 leads V2 by pi over 4 radians, or that V2 lags V1 by pi over 4 radians. If the unit of omega t is degrees, then the phase shift, theta 1 minus theta 2 equals 45 degrees. It is said that V1 leads V2 by 45 degrees, or that V2 lags V1 by 45 degrees. Experiment 4.4.1. Construct this circuit. Set the voltages of the signal generator channel 1, VCH1, and that of channel 2, VCH2 as follows: VCH1 equals V1 m sine omega t plus theta 1, VCH2 equals V2 m sine omega t plus theta 2. Where the amplitudes are V1 m equals V2 m equals 3 volts, or V1 peak to peak equals V2 peak to peak equals 6 volts, the frequency f is 100 Hz, and the phase shift theta 1 minus theta 2 is pi over 2. Measure VCH1 and VCH2 using the oscilloscope. The answer to experiment 4.4.1. These are the measured waveforms. The orange line represents the voltage of channel 1, VCH1, and the purple line represents the voltage of channel 2, VCH2. The amplitudes V1m and V2m were 3 volts. The frequency f was set to 100 Hz. So, the period t equals 1 over f equals 10 milliseconds. One period of these waveforms took 10 divisions, and each division represents 1 millisecond. Therefore, the period t is 10 milliseconds. The time shift delta t was 2.5 milliseconds, and the phase shift of V1 relative to V2, that is theta 1 minus theta 2, was 90 degrees. If the unit is radians, the phase shift converts to pi over 2 radians. Experiment 4.4.2. Construct this circuit. Set the signal generator to produce V equals Vm sine omega t, where Vm equals 3 volts. Set the frequency f of the voltage V to 2 cases, one is 10 kHz, and the other is 100 kHz. Measure V, Vr, and the time shift, denoted by delta t, between V and Vr. This photo shows the appearance of a capacitor. The value of capacitance is printed on the body of capacitor. The unit is the picofarad. 103 equals 10 times 10 to the power of 3 picofarads, equals 10,000 picofarads, equals 0.01 microfarads. This is the symbol of a capacitor. This shows a wiring diagram of the experimental circuit. This shows a 3D wiring diagram of the experimental circuit. These photos show the RC circuit on the breadboard, and the wirings between the RC circuit and the ADALM2000. These were the measured waveforms of the source voltage V and the voltage VR across the resistor R. The time shifts delta t were 16.0 microseconds in A, and 0.26 microseconds in B. Exercise 4.4.1. This is your homework. These are the results of previous experiment. Calculate the phase shifts theta s of V relative to VR in A and B. Answer in both units of degrees and radians. Experiment 4.4.3. Pause the video, and follow the instructions. Measure V, VR, and the time shift delta t, between V and VR. This photo shows the appearance of an inductor. It looks similar to a resistor. You can distinguish an inductor by its green body, whereas a resistor typically has a brown body. This is the symbol of an inductor. The inductance of an inductor is indicated by a color code. The inductor in this photo has the code with brown, black, orange, and silver bands. This is the same color code table as for resistors. According to this table, brown is 1, black is 0, orange is 3, and silver is plus minus 10%. The unit of this inductance is the microhenry. Thus the inductance of this inductor is 10 times 10 to the power of 3 microhenries plus minus 10%, equals 10 millihenries plus minus 10%. These were the measured waveforms of the source voltage V and the voltage VR. The time shifts delta t were 8.40 microseconds in A, and 3.97 microseconds in B. Exercise 4.4.2. This is your homework. These are the results of previous experiment. Calculate the phase shifts theta s of V relative to VR in A and B. Provide the answer in both degrees and radians. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.